Hey everyone, welcome back to another video by Camroom 5. Today's video is going to be the first in a series of videos for the A-level practical examination. So we will be dealing with the A-level P3, which is obviously the practical exam. In today's video, we will be seeing how many different kind of practicals can come, and we will start with the very first kind, which is something you would be aware of from your O levels, that is titrations. So let's begin. What kind of experiments come in A level P3? By the way, the A level P3 is a 2-hour exam, and it normally has 2 questions, but again, normally it might have 3 questions also. So let's begin. The first kind of question that you can encounter in the A-level practical examination is the titration, which is normally question 1. In titrations, you use volumetric analysis. So you have a volumetric analysis where you deal with the volume of one chemical required for the reaction with another chemical. Titrations could be of various categories. For example, it could be acid-base titration. It could be a redox titration where you are reacting an oxidizing agent with a reducing agent. Another very unique category is the thermometric titration. In a thermometric titration, you keep a track of temperature changes during reactions, so you also have a thermometric titration. Another kind of question that you might encounter a lot in A-level P3 is the gravimetric analysis. In a gravimetric analysis, you basically measure mass changes in substances. So you measure the changes in the mass of values, in the mass of substances. Third kind of question that normally is encountered in A-level practical examination is the qualitative analysis. So you might encounter a qualitative analysis question. In a qualitative analysis question, you basically identify the cations and anions in a given sample. Anions in a given sample. Make sure that you have the qualitative analysis table at the end of the exam. You don't have to ratify that. It is already given, but you will have to know how to use that table. Another kind of question that you might encounter is a question on rate of reactions. So you also have rate of reaction questions where you see how fast the reaction is going on. For example, you can have gas collection, or you could have the iodine clock reaction. These are the examples, by the way. You could have some other questions also from rate of reaction. In our today's video, we'll start discussion about titrations, and we'll see what titrations are and how we do them. So let's begin. When we talk about titrations, in titrations there are few key terms that we should know. So when we talk about titrations, we always have few common apparatus and few common terms. So let's write few important definitions. The first definition we have is a titer. A titer basically is the volume of concordant readings from the burette. We should know what a burette is because we will be using a burette very frequently in all kinds of titrations. Now, what's a concordant reading? When you use a burette, you get the volume used. So basically, in easy words, the titer is the volume used from burette. But then why I use the word concordant? What does the word concordant even mean? So the second definition is concordant, or you can say concordant readings. When you are using a burette, you get the volume used for whichever chemical is in the burette. A concordant reading means two readings from the burette, any two readings from the burette which are at least within 0.10 centimeter cube of each other. So it means two readings of the burette which have a difference of maximum 0.10 centimeter cube, not more than that. Let me give you an example. For example, 21.70 centimeter cube and 21.80 centimeter cube are concordant. So you can use these two volumes for your future analysis and for your future calculations. But 21.70 centimeter cube and 21.85 centimeter cube are not concordant. You can't use these two volumes for your calculations. So you will have to perform another titration. Another definition that normally comes in your titration that you should be aware of is the error. Error is basically from any apparatus. So the uncertainty from any apparatus, is the error. It is normally recorded as a percentage. So it is recorded normally as a percentage. To understand the idea of errors better, let's go for these apparatus. These are the following normally used apparatus which we come across during titration experiments. So when we talk about titrations, we have these few pieces of apparatus. The first one you see on the left is a burette, very frequently used. The second is very less commonly used. It's a measuring cylinder. Then you see a volumetric pipette, and then you see a conical flask. A burette starts from the value of 0.00 and ends at a value of 50.00. Make sure you always use two decimal places in burette readings. It's very important because a burette is accurate to nearest 0.05 centimeter cube. Your burette value will end at a 0.00 or 0.05. So you have to use two decimal places. And the second decimal place, remember, second decimal place can be 0 or 5 only. You can't use a second decimal place of 1 or 3. I'll give you more examples on it, don't worry. A measuring cylinder is not very accurate. You use no decimal place here. You use no decimal place here. It is just for rough estimations. A volumetric pipette has a mark, it has a specific mark, and you always fill the value by creating a suction. You put it in the liquid, whichever container that is, and then you create a suction, and then the volume is filled till the mark. You make sure that even pipettes are written up to 2 decimal places. So you write 2 decimal places values. For example, 25.00 centimeter cube or 10.00 centimeter cube. A conical flask is not for measurements. Remember, a conical flask is not for measurements. You just perform the reaction here. Even though a conical flask has some graduations on it, even though you will see some lines here which will give you 10, 20, 30 centimeter cubic values, but you never use it for measurements. Moving on to a titration question. The first thing that the titration question hints is always about the name and the values of the chemicals. So we are looking at a question right now, and we'll see what various terms the question uses. Let's look at this question. It says you are required to find the percentage purity of a sample of sodium carbonate. Fa1 contains 4.50 gram per decimeter cube of the impure sodium carbonate. Fa2 is a 0.50 mole per decimeter cube hydrochloric acid. So you can see it is probably an acid-base titration. Moving on, part A says dilution of Fa2 which was the acid by the way. By using a burette, measure between 33.00 and 34.00 of Fa2 into the 250 centimeter cube graduated flask. Remember, a graduated flask is also known as a volumetric flask. It looks like this something. It has a narrow neck and then it is flat from the bottom, and it has a mark which represents 250.0 centimeter cube. Look at the question again. The question wants you to fill the burette with Fa2 and transfer between 33.00 and 34.00 centimeter cube of Fa2 into a graduated flask. So you will fill the burette with it and then you will make sure to transfer it. Record your burette readings and the volume of Fa2. In order to record burette readings, I'll show you how to make the table. You make the table with ruled lines. You don't make it with rough hand. You have to make it using ruler and a pencil. I'll show you important headings to be written here like this. The first heading should be initial burette reading. You can't write them in short form. You can't write IN burette reading. IN to signify initial will not be accepted. Make sure to write a slash n centimeter cube. Then you make a line to end the column, and then you will write the second heading, which is final burette reading, and then you write a slash in centimeter cube again. You make another line to end the column, and then you write volume of Fa2 used, and then slash centimeter cube. The headings are really important, so make sure you write the correct headings and then you write slash and the unit every time. Imagine that your burette was filled to a value of 0.10 centimeter cube. It's okay, you don't have to start from 0.00. And then by the end of the usage of burette, your value came to around 33.60 centimeter cube. To find the volume used, you minus the initial volume from the final volume. So it's 33.60 minus 0.10. So it becomes 33.50. So that is 33.50 centimeter cube. It is between these two extreme values. So right now we are okay with it. We don't have to worry about it. This is how we draw the table. Now the question says make up the contents of the flask to 250 centimeter cube with distilled water. Place the stopper in the flask and mix the contents thoroughly. You will put a flask lid on your volumetric flask and then you will obviously shake it so you have the final volume to 250 centimeter cube. Fill a second burette with Fa3, the diluted solution of hydrochloric acid. Remember, Fa3 was recently made in a volumetric flask. Pipette 25.0 centimeter cube of Fa1 into a conical flask and add few drops of the methyl orange indicator and titrate with Fa3. Now I have already drawn a table with you guys and I want you to see how the table has certain errors. Note that the question here says perform a rough titration and sufficient further titrations to obtain accurate results. Now let's see few errors here. The first error I can see is there is no unit used in the third row. So you have to use units every time. The second error which I can see is here and here 2 dps are not used, which is again something that you will be penalized for and you will lose your marks here. Let's identify what the student has done and whether it will gain the marks or not. When he has performed the first titration, he got 21.50. Remember, the first titration is a rough titration. You cannot use rough titration values for any average volume calculation. Your rough titration is not recorded for concordant readings. So first is rough titration. His second titration started from 21.50 and gave a final volume used of 21.70 centimeter cube. His third value gave 21.60 centimeter cube and the fourth value was 22.50 centimeter cube. You might be like, sir, that's okay. We have already deducted marks for not writing the units and for not using the decimal places. So everything else seems perfect. But there is one error. Why has the student performed the fourth titration? The second and the third titrations were concordant. Second and third were concordant. They were within 0.10 range. So why was the fourth titration done? And that will be penalized by not gaining a mark. So do not perform extra titrations because you will lose marks. So far what we have learned is that in A-level practical examination there are certain kinds of questions that you come across. Then we looked at titrations and some important definitions like what's a titer? It's the volume used from the burette. We looked at concordant readings which are within a range of 0.10 centimeter cube. We looked at error. We noticed that there are few important pieces of apparatus that we use like the burette, which is written with 2 decimal places, a measuring cylinder which has no decimal places, a volumetric pipette which also has 2 decimal places, and a conical flask which is never used for volumetric measurements. Then we looked at a question and then we saw how the tables are drawn. We looked at few do's and don'ts for drawing a table. In the next video, we will do a complete question with all its calculations. Stay tuned guys. Thanks.